Abeokuta Grammar School online class and to take mathematics. My name is John Abe. What we are going to discuss today is trigonometry. What do you understand by trigonometry? It is the study of the triangle in relations with the sides and angles. Now, we have different types of triangles. We have obtuse angle, scaling triangle, we have equitriangle, we have equilateral triangle, we have the right angle triangle. I'm going to consider the rules this morning that will be applicable to all these triangles. Pythagoras rule, the sine rule. At the end of the class today, we are able to define what is meant by the trigonometrical ratios and Pythagoras rule and the sine rule. Trigonometry, solving triangles. Trigonometrical ratios are the basic signs that we normally use to solve triangle. Now considering this triangle CBA with angle theta here. We have 4 meters for line CB and 3 meters for line AB and unknown for this particular line. I said the 3 basic trigonometrical ratios. We have the tan theta, tangent of angle theta, we have the cos theta, and we have the sine theta. Now, tan theta means opposite side all over adjacent side, while the cos theta is adjacent side all over hypotenuse side. Hypotenuse side, while the sine theta is opposite side all over hypotenuse side. Hypotenuse side. Now, from here, any side facing angle 90 we refer to this as hypotenuse. The included angle given here is angle theta. And any side facing that included angle is known as opposite side, while the third side will be the adjacent side. And we call these three, the tangent theta, cos theta, and sine theta, the basic trigonometric ratios. We have the other three, we refer to this as the derived trigonometric ratio, where we have the secant, we have cosecant, and we have the cotangent. The secant, as you know, is hypotenuse side all over adjacent side, while the second is hypotenuse side all over opposite side, and the cotangent is adjacent side all over opposite side. This is the same thing as the second is the same thing as 1 all over cos, while cosecant is the same thing as 1 all over sine, and this one is the same thing as 1 all over tan. Now, in solving the triangle, in solving this triangle, we are given, for example, when you are given a triangle ABC, with angle B equals 90 degrees. Then you are asked to solve that triangle to find the tan theta, to find the cos theta, and the sine theta. From the diagram that we have have seen from above, your sine theta here is equal to opposite side all over the hypotenuse side. But the hypotenuse is yet to be known. What we need to do to know the hypotenuse side is to first of all use the Pythagoras rule. Pythagoras rule says that the hypotenuse raised to power 2 is equal to the sum of the two other sides, that is opposite side plus adjacent side raised to power 2. From the figure given above, the opposite side is 3 meters. That's 3 raised to power 2, and the adjacent side is 4 meters. That's 4 raised to power 2. Then the hypotenuse now will be equal to 9 plus 16, which is equal to 9 plus 16 will give us 25. Then hypotenuse side will be equal to root of 25, which is 5 meters. Now, to find the ratios of tan, cosine, sine, secant, cosecant, cotangent here from this diagram, my tan theta, tangent of angle theta, will be opposite side all over adjacent side. The opposite side is 3, adjacent side is 4. So you have 3 all over 4. For cos theta is adjacent side all over hypotenuse side. The adjacent side there is 4, and the hypotenuse side is 5. Calculated. It's through calculation. Calculated. Likewise, the sine theta will give us the opposite side all over hypotenuse side. That's 3 all over 5. 3 all over 5. These 3 are called the basic trigonometric ratios. Why the derived one? Secant. Secant is hypotenuse side all over adjacent side. Hypotenuse side all over adjacent side. That's 5 all over 4. And the cosecant, which is one of the derived, is hypotenuse side all over opposite side. That is 5 all over opposite side, which is 3. While the last derived one, we call it the cotangent. And the cot theta, calculate as cot theta, it will give you adjacent side all over opposite side. This is adjacent side all over opposite side. That's 4 over 3. Application. Application of this Pythagoras rule. The second example, second application. Now, when we are giving another application, when we are giving a triangle KLM with 12, and we have nothing here, X, and we have 30 here. You are asked to find the letter angle X. To find the letter angle X here, you know, I said the other time that anything facing angle 90 is hypotenuse. So this 30 is our hypotenuse, and the included angle theta here, the angle theta here is X. Angle theta is our angle, and this line LN is our side. Now, to use the Pythagoras rule, by using Pythagoras rule, rule, then we have Km raised to power 2 is equal to KL plus Ln. And we know our Km is 13. So 13 raised to power 2, and our KL is 12. 12 raised to power 2 plus Ln or no. But our Ln is represented by x. Then 13 raised to power 2. What is it by using your calculator? Viewers at home. 13 raised to power 2 is 13 times 13, which is 169. And 12 raised to power 2 is 12 times 12. By using your calculator, so you have 144 plus. But don't forget, Ln is represented by letter x. So you have x raised to power 2. Then the next thing is to collect the line times. So x raised to power 2 now will be equal to 169. When you move this 144 to the other side, it will be negative. So you have minus 144. Then x raised to power 2 now. 9 minus 4, you have 5. Then 6 minus 4, you have 24. 25. 25. Then, when you have that, your x raised to power 2, as you know, is 25. Then x is equal to root of 25. X is equal to 5 meter. Don't forget, unit is very, very important when we are dealing with this. You have seen from here how we use the Pythagoras rule for the three trigonometric ratios. I said the basic trigonometric ratios are the sine where we form it from the show cartua. Show means sine is opposite of the hypotenuse, car cosine adjacent of the hypotenuse, and tua, that is the opposite of tangent is opposite of adjacent. Now, I said we have the derived one. The derived ones are the cosecant, the secant, and the cotangent. That's the application of the Pythagoras rule. That will now allow us to move on to the sine rule. I said earlier on, when we are dealing with the solving triangles, the right angle triangle is meant for the Pythagoras rule. We have other types of triangle, obtuse angle, arc angle, where we are going to use the arc angle as an example of sine rule. The sine rule says that A all over sine A is equals to B all over sine B equals C all over sine C. You have this. This is a triangle. It's not a right angle triangle. You have A, B, C. The side facing angle A, we name it small a, and the side facing angle B, we name it small b, and the side facing angle C, we name it small c. We use capital letter for the angle. This is angle A, and this is angle B, and this one is angle C. Why we use the small letter for the corresponding side. Now, the sine rule now says that A all over sine of A is equal to B all over sine of B is equal to C all over sine of C. That is, or the other way around, you can take the denominator denominator to the upper side, but let there be uniformity. You can have it as sine A all over A is equal to sine B all over B and sine C all over C. Application. That is, assuming you want to solve this particular triangle. Now, given a triangle ABC, that is, you are given triangle ABC in this form. Application A, B, and C. You are giving this to be 50 degrees, and this one 30 degrees, and you are giving this to be 5 meters. Then, from this, you are asked to solve this particular problem. Before you can solve any problem on sine rule, condition, which is different from the Pythagoras rule, you must have two angles given on one side. Or the other way around, two sides and one angle. Now, in this case, this side facing A, angle 30, is small a, and the side facing B is angle B is small b, and the side facing C is small c. So the letter angle that we are supposed to solve here is letter B. Now we can use the relations A all over sine A is equals to B all over sine B, because we are given the matching pair here, that is angle A and side A, and we are given angle B, but we are not given side B. So that's the main reason why you use A all over sine A is equals to B all over sine B. Then we stop in the values given to us. The value given to us, do you know A is 5 meters. So take it, that's A is 5 meters, you can put it down. Do you know angle A? Angle A is 30 degrees. Do you know B? No. Do you know angle B? Angle B is equal to 50 degrees. Then we stop in that value in this relation. When we stop in the values, so we have 5 is my A, my sine A is sine of A is sine 30 equals B is unknown, and my sine B here is sine 50 degrees. The next thing is to do the cross multiply and make your B the subject of the formula. So my B will be equal to 5 sine of 50 degrees divided by sine 30 degrees. I want you to use your calculator now to get the values of sine 50. Yes? Yes? What is sine 50? Use your calculator, or you can use your 4-figure table. What's your sine 50? Correct. You are giving 0.7660. Now, sine 30. You can still use your calculator to calculate sine 30. What is sine 30? Sine 30, yes, anybody? Sine 30 is the same thing as well as 0.5. Then you multiply. 5 times 0, that's 0. 5 times 6, that's 30. Then put down 3, that's 0. And 5 times 6 is 30, plus another 3, that's 3, 33, and 5 times 7. What do you have? You have 3.33. 3.33, 0. You can nullify the 0 at the back. Divided by 0.5. When you divide it, the values of B now will be equals to 7.66 meter. Don't forget, it's very, very important. The unit is very, very important. Now, at times in WAEC or NECO, you'll be asked to round up to the nearest degree, nearest tenth, or 3SF in order to withdraw the accuracy mark from you. Now, when it is 7.666, is 3 significant figure, 3SF, or you can have it 2 decimal places. 2 decimal places. Another example. Another example, application 2. Application 2, that's 1. When you are given another side, but you are not giving, I've solved application 1, as I said, when you are giving 2 angles with a side. But I want to give 2 sides now. 2 sides with 1 angle. A, B, and C. Then you have this to be 5 meter, this one 4 meter, and this one 30 degrees. The case 1, application 1, you are given 2 angles and 1 side. But in this application 2, you are given 2 sides and 1 angle. So you state whatever you are given. I said before you can use sine rule to solve triangle, you must have 2 sides, 2 angles and 1 side, or 2 sides and 1 angle. So angle A here is 30 degrees. Angle B is not given, and B is not given. Side B is not given, Side C is 5 meter, and you are given side C is 1 meter. Then you are asked to calculate the given angle here. Now you can use A all over sine A is equal to side A is 4 meter, as you know. A all over sine A, that one has PR side. Now A all over sine A, then you have C all over sine C. The other case, we use A all over sine A is because we B all over sine B. But in this case, you are given 2 sides and equal angle. We plug in the values. A is 4. Your sine A, is it given? No. Is it given? Yes or no? Viewers at home, your sine A is sine 30. YC, is it given? Yes, it's 5 meter. And your sine C is not given. Then what are you going to make as the subject of the formula here? You make sine C the subject of the formula. Then you have sine C is equal to 5 sine 30 all over 4. Then you have 5 times what sine 30? As you've known, you have 0.5. Then you have your sine C now to be equal to 5 times 5 will give you 25. 5 times 0, that's 0 plus that 2, that's 2.5 all over 4. Then you have 0.4 goes in 2, that's 0. In 25, you will have, what is it at home? That will be 6. Remainder 1. In 10, you have 2. 5, 0. Then your C, we are finding angle here. Angle C now will give you arc sine of 0.6250. Now, I've said I want to find this particular angle. Now, what I want you now to take note, I want you to take note of what you have learned, type of triangles, the definition of the trigonometric ratios, the sine, cosine, tangent, isect is the basic trigonometric ratio. While the second, the cotangent, and the second are the derived one. Now I want you to have this assignment against the next class. Now, the assignment, question number 1. Question number 1, given this particular triangle. This triangle, the triangle VUW with angle 60 here, you have 3 centimeters here, and you have that. So what you need to do now, find or determine tan 60 degree, cos 60 degree, sin 60 degree, cot 60 degree, secant 60 degree, and cosecant 60 degree. That's question number 1. Question 2. Use sine rule or otherwise to solve the triangle below. Yes, that particular triangle, you have KLM with angle 30 degree. You have 5 meter here, you have 6 meter here. 2. That's 2, that's 1. The next one, you are given this. PQR, you have angle 30 here, angle 60 here. So I have with one side. Then that side will give you what? You have this side to be 8 meters. With a little thing that we have done this morning, we have known what is meant by the trigonometry. We have known the types of triangle that you have, and so on and so forth. And I want you to lay your hands on this particular problem against the next class. Good day, my dear student. I still remain Mr. John.